Okay, let's break this down. You guys, first we cleared fractions, right? So to clear the fractions, we decided we were going to distribute a 4 through. Okay, that part looked good. Remember that when I'm clearing fractions and I distribute to a fraction, it's always easiest to divide first and then multiply. You end up with smaller numbers that way. So 4 divided by 4, that cancels the denominator. 4 over 4 reduces to 1, which is what's left over to multiply by the numerator, right? So I end up just getting a 1. I'm multiplying by a positive, so the inequalities don't flip. They stay the same. 4 times 6 is just 24, minus, when I distribute to this fraction, 4 over 4, you already told me, reduces to 1, times 3 gives me 3, and then there's an x, so I get minus 3x. And when I distribute 4 to that 3, I get a 12. Okay. So now we've got our 3 columns, first column, middle column, second column, or left column, middle column, right column. I'm trying to isolate the x in the middle column. So what would the 2 algebra steps be that I'd have to use to get that x by itself in the middle? What would I do first? Got to subtract 24. And how come? Because we're using inverse operations, right? If we think about PEMDAS, that's the isolate direction, right? Bottom to top. So first we're going to have to add or subtract. Okay, good. So we are subtracting 24, but instead of from both sides, it's from all 3 parts, right? I'm subtracting 24 all the way across. So those guys cancel, and what's that give us? Negative 23. I didn't multiply by a negative or divide by a negative, so the inequalities stay the same. I get a minus 3x, and I get negative 12. Okay, what's the next step to isolate x? Divide, good, divide by negative 3. All right, so if we do that, if we divide all 3 parts by negative 3, and keep in mind I'm dividing by a negative, so what do I have to do? If I multiply or divide an inequality by a negative, I always have to flip around the inequality signs. Good. Okay, so that's going to turn into switch directions. That's going to switch directions. Over here I get negative 23 divided by negative 3. Negative divided by negative is positive, but I can't reduce that fraction. I'm stuck with a fraction. That's all right. We can get fractions in our answers, but I didn't have to battle them the whole way. I only get them in the answer, right? So I've got my x in the middle. It's going to be less than or equal to 23/3, and it's going to be greater than negative 12 divided by negative 3 is what? 4. Good. Now remember, we always start in the middle, but this is backwards, isn't it? This part right here, that part says 23/3 is greater than or equal to x. Okay, but we'd rather start with the variable. That's the same thing as saying x is less than or equal to 23/3, right? Okay, how about this other part over here? Starting in the middle, that says x is greater than 4. Well, 23/3, if I type that in a calculator, I get something like 7.6 repeating, right? I get 7 point something. That's bigger than 4. So what's wrong with this statement? It's backwards, right? It's backwards. I want to have the x in the middle and have the x in the middle greater than the bottom number and less than the big number, right? So I've got to flip this whole thing around. The x is going to stay in the middle, but this blue part, x is less than or equal to 23/3, I'm going to flip that around and put that on the right instead of the left. So it looks like that. Everybody see that? They say the same thing, don't they? X is less than or equal to 23/3. X is less than or equal to 23/3. Okay, how about the purple part? Well, I want to flip that around and put that on the left. x is greater than 4. So it looks like that. Okay, makes sense? Why do we need it to be that way? Well, because if I graph it, this makes sense. Think about those numbers. 4 and 23/3 would be up here just past 7. 7 and 2/3, right? So 23/3 would be like right here. 4 would be, whoops, 4 would be right there. I want all the values greater than 4 and less than 23/3. Wouldn't that just be everything between those two extreme values, those endpoints? Okay, give me 1 to 5. Because that's the hardest one I could come up with. If you can deal with that compound inequality, you can do any of them. That's a tough one. There's a lot going on there. Okay, is that making sense? Okay, all right. Okay, so today I want to push forward a little bit more. Let's look at some weird ones, some very strange ones. This one seems like it's going to be a piece of cake, pretty simple, but the result is a little strange. Let's take this first. Is that an and or an or compound inequality? Why? Because of that symbol? Is that an and symbol or an or symbol? What's the or symbol? A V. Okay, so if V is or, that's or. When I turn it upside down, what does it become? And. Yeah, and or are just always the vertical flips of each other, right? I topple one over to create the other one. So this is actually an and statement. I got two things going on. This means, remember, this means and. Okay, so it's an and statement, but it's given to us as two separate inequalities. And they both, okay, you tell me, if it's an and statement, how many of those have to be true at the same time? Both, right? Or statement, only one of them has to be true at a time. And statement, they both have to be true for the and statement to be true. Okay, so let's look at this first part. What are the two steps in order to solve for x? Everybody? Well, what do you do first to isolate? Subtract 5 and then divide by 2. Okay, so if I subtract 5, I get 2x is greater than 14. Divide by 2, and I get x is greater than 7. Okay, x is greater than 7. And how about the other side? What are the two steps in order to solve for x in the red inequality? Add 6 and then divide by 4. So if I add 6, I get 4x is greater than 24. Divide by 4, and I get x is greater than 6. That's a little strange. X is greater than 7 and x is greater than 6. Anybody know what the solution is going to be there? It's an and statement, so they both have to be true at the same time. X is greater than 7 and x is greater than 6. What values of x make both of those true at the same time? Okay. Yeah. Huh. Maybe. Let's look. You gave me just some integers, but we're on the right track. Let's graph them and see. The important numbers would be 6 and 7. The graph of x is greater than 7, doesn't that just look like an open endpoint graph to the right? X is greater than 6 looks like an open endpoint at 6, and I graph to the right. Now it's easy to see with the graph. The solution to that compound inequality, to the and statement, is only going to be the values of x where both of those are true at the same time. So it's going to be where the graphs intersect or overlap. What's the only values of x an ant could be walking on and be in both the red and the green regions at the same time? Greater than 7. Yeah, everybody see that? That's where they overlap. And so the solution is going to be that. Okay? So solution is x is greater than 7. That's it. Okay? Because that's where they intersect. Okay. What if it were an or statement? What if we ended up getting x is greater than 7 or x is greater than 6? What would the solution have been? Because then only one of them has to be true. Then we'd want to know all the places where an ant could be walking and be on either the red or the green, or maybe even both. Greater than 6. Yeah, if it were an or statement instead of an and statement, it would be all the values of x greater than 6. Okay? Let's try another one. Is that an or an and? That's an or, isn't it? Yeah. Okay, so we'll do this one quickly. Would everybody agree that to solve for x in that first inequality, I subtract 6 and then divide by 4? So that's going to give me 28 on the right. X is less than or equal to 7. Agreed? Did I do that right? You better double check me. Okay. How about this side? Add 6 and divide by 3. Okay, let's make this an or statement, and it's easiest to graph them. So my numbers are going to be 4 on the left and 7 on the right. If I graph x is less than or equal to 7, that's a closed-end point at 7, graph left. X is greater than or equal to 4 is a closed-end point at 4, graph right. Okay, so you guys think about that for a second. When is x less than or equal to 7 or greater than or equal to 4? What's it going to be? In between the two, that interval would be the place where they're both true at the same time, right? So that would be a solution if this was an and question. What do you think? It's going to be outside. It's going to be everywhere, isn't it? Because really what we're asking is what are the regions that are either green or red? The fact they could be both at the same time, but I just want to find every place that's either green or red or maybe even at the same time, right? We're taking a combination of all the regions from either one of those inequalities. So what's the answer then? All reals. Yeah, it's everywhere. It's all reals. Because it's an or statement, the solution is all reals. How would I write that using interval notation? Well, it's that purple interval. It goes forever in both directions. So how would that be with interval notation? Yeah, absolutely. It goes all the way from negative infinity to positive infinity on the right. So that's how we'd say all reals with interval notation. Okay? How we doing? Give me 1 to 5 on that. Those are weird. Yeah, that's good. That's good. These are usually very tricky for people. Okay, try one. Go back to boards. Try this one. Oh, are we out of here in 5 minutes? Okay, we'll just try. Get a start on it. We'll finish it up tomorrow if we need to.